All right, the three pillars of AI as we see them today. Now, this is not well known. Most people are really focused on generative AI at this point and how they use that, and we'll talk about that. That's what people are interested in right now at this point in time. But I did write and release a book called Causal AI: The Next Evolution in AI, and what we see is that across the three pillars, causal AI is the one that we're going to be using in the beginning of the process, or at least I think we're going to be using it at the beginning of the process. Causal AI allows us to predict why things happen. Why do people do what they do? Why do people respond to certain prices? What happens when we try certain drug interventions in a clinical trial? Why does the body react the way it does? Why do certain price points work? Why do certain supply chains work? It's all about why things happen. And we're all very interested in that. The classical predicting what, the generative of predicting how to respond are all great, but we really do need to know more about why things happen. This is all based on a relatively new branch of calculus. Maybe some of you have heard of a professor. His name is Judea Pearl. He's a professor at UCLA in Los Angeles. And he and his graduate students and his collaborators over the last 30, 40, 50 years, he's been working on this for quite some time, have really brought this forward in a way that it's practical. It's not widely understood at this point, and there are only a few companies out there like Causal Lens and Geminos and a few companies that are trying to take the early stage research that's been happening in research institutions and academic institutions around the world and turn that into software. And Dr. Pearl's work in the new branch of calculus is making this a reality. So we now have the capability to take the early work of these researchers that I talked about in academia and research institutions and the work that was done in Amazon and Microsoft and start to build predictive systems that actually tell us why people are going to do what they do. It's rather unusual in the field to see companies like Amazon and Microsoft coming together, but they started out with a package called DoY, and now that's merged together and it's called PyY. So if you're out there looking at Causal AI, take a look at PyY, and it's a very intriguing piece of software and technology. So that's Causal AI. We're going to be able to look at why things happen and predict that with a solid degree of certainty. Classical AI, we're all well aware of this, based on all the different technologies and techniques that we use: classification, clustering, neural networks, all those different things that we've done for years and years. So traditional classical AI is widely used, but only really understood by the AI practitioners and some technologists. What I was saying before is that when I'm working with a CIO or maybe a CTO, it's often that they're technologists that understand transaction processing and architecture, but don't really understand analytical processing and AI. So, it's a field that people talk about a lot, but there's not a great deal of widespread understanding of it. There is an abundance of tools out there, closed source or proprietary tools and open source tools, and applications and use cases are ubiquitous. As I said in my introduction, I've helped put in over 100 AI applications at this point in my career. So plenty of use of traditional classical AI. Now, generative AI, this is something that has burst onto the scene in the last year. It's been around for a couple years, and we've actually been doing natural language processing for about 10 years now. So, the generative AI, generative AI technology is based on neural networks. It is widely used at this point, but not well understood. So, we have put out a private secure chatbot in my day job at EY, and we have hundreds of thousands of people using that each day. And each of the community models that are out there from Anthropic and Cohere and all the different companies that are out there have millions of people using this. So we have lots and lots of people using this technology. And there is, some real opportunity in the marketplace for proprietary models as well as open source models in addition to that. And the applications and use cases are being explored are ubiquitous. I've seen hundreds and hundreds of use cases at this point, writing presentations, writing code, doing different things like that. So this is the three pillars of AI that we see today. And I expect that in the next year or two, we're going to start to see composite applications with causal AI, traditional classical AI, and generative AI as a component of those applications. Generative AI, the what and how. As I said, if you've used any of the natural language processing tools that are out there in the last 10 years, like I said, BERT or Roberta or any of those tools and technologies, you already understand and have a good foundational understanding of generative AI. Generative AI, what I have seen over the last year that I've been delving deeply into it, is very good at summarizing large amounts of unstructured information. It's also very good at finding specific information in a massive corpus of information. And then it's also very good at generating a narrative. So let me talk about a couple use cases there. So this actually, you can connect with it. So let's say that you work at an organization or a governmental function or an academic institution, and you have a collection of PDFs or electronic documents that is, let's say it's 10 million documents in depth. Now, it's very hard to look across 10 million documents and find anywhere where there might be an error or it might be out of date or something like that. So one of the things that generative AI is very good at is that we take those documents and we run them through what we call an indexing process. And if you've done NLP, you've indexed information before. And even if you've done structured information like numbers and rows and columns and tables, you've indexed information as well. So it's just a little bit different indexing process, but it's very easy to do. You run the documents through an indexing process, turns the words into vectors, creates embeddings around those documents, and you store those in a vector database. Then once you query it, you send your query into that vector database and maybe an unstructured data store into a large language model, and it comes back, bringing back the results, the relevant results, and the narrative that was generated around that. What does that do for you? It allows you to look into a large amount of information and bring back very pointed results. You can then look at it and say, oh, well, hey, this document is out of date. We revised it in 2024, but this was only updated in 2022. So it's a very good tool for finding out-of-date information and updating your corpus of knowledge. How is this actually happening? It's generative AI is rapidly evolving. I have rarely seen something move this fast, this far in such a short amount of time. We are really working with immature technology. That doesn't mean that it's not valuable and that it's not good to use, but it is changing very quickly. So, you go after or you work with or process large amounts of unstructured information that can be quickly ingested and leveraged. The great thing about it is that you have access to all this information, but as I said earlier, it might not all be up to date and accurate the way you expect it to be. The information lifecycle of the source information is going to be examined. We've looked at a number of these processes, and we found that we're not very good at keeping these up to date. We write new documents, we put them into repositories. We sometimes don't update documents the way we need to, and we have some information quality issues there that we need to look at. So building your large language model, building your own large language model may sound exciting, and it is exciting, but it's very costly, and you need access to a significant amount of compute power to actually do it. So while sometimes you think, hey, this is really fun and interesting, it's very costly, time consuming, and you might not get the results you want. So I'm not a big believer in everybody going out and building their own large language model. That doesn't mean anything about fine tuning. We'll talk about that in a few minutes. But, having a good information architecture and management process is key to your success. While we're talking about new technology and generative AI, it still comes down to information management fundamentals, having good information, having quality information, and managing that in a repeatable, governed manner.